Institute of Engineering and Technology. Today we are going to study few more topics of Laplace transform. So let's begin with the first topic, that is integration of Laplace transform. If Laplace transform of ft is equal to f of s, then Laplace transform of ft upon t is equal to integration s to infinite fs ds. Okay, now let's see its proof. If Laplace transform of ft is equal to f of s, and this is the main formula, that is integration 0 to infinite e raised to minus st ft dt. Okay, now what we will do, we will integrate both the side with respect to s from s to infinite. Okay, so what you will get, integration s to infinite fs ds is equal to integration s to infinite integration 0 to infinite e raised to minus st ft dt ds. Okay, just applying integration on both the side. Now since s and t are the independent variable, we can interchange the order of integration. Okay, so what you will get, integration this 0 to infinite, take it outside. Okay, and this s to infinite is inside, e raised to minus st ft. Now in place of dt ds we will write ds dt. Okay, so what we will do, we will integrate this with respect to s and we will keep t as a constant. Okay, so on integrating, what we will get, e raised to minus st upon minus t, because t is constant, ft as it is, and the limit is s to infinite, dt as it is. Now substitute the limit, so what you will get, e raised to minus infinite, that is 0, right? Minus, now this is 0, so I am not writing whole term. Okay, minus, now lower limit. So in place of a s, we have to write s only. Okay, so here this is e raised to minus st upon minus t ft dt. Okay, dt this as it is, this minus minus will become plus. So what you will get, integration 0 to infinite, just e raised to minus st, and bring this ft and t together. Okay, so this is ft upon t dt. Now we know that this we can write as Laplace transform of ft upon t. So finally Laplace transform of ft upon t is what, integration s to infinite fs ds. Okay, so whenever we have t in the denominator, okay, so what we will do, we will just integrate this fs from s to infinite with respect to s. Okay, now let's solve example. Find Laplace transform of 1 minus cos 2t upon t. Okay, now we have t in the denominator, so we will use this formula, that is Laplace transform of ft upon t is what, integration s to infinite fs ds, right? So firstly what we have to do, this is ft, right? So first we will find the Laplace transform of this term. So Laplace transform of 1 minus cos 2t. Apply the linearity property. So Laplace transform of 1 minus Laplace transform of cos 2t. Okay, Laplace transform of 1 is 1 upon s, and here we have s upon s square plus 4. Okay, now if you will divide it by t, so 1 minus cos 2t upon t, so we will get this formula, that is integration s to infinite. Fs is what, 1 upon s minus s upon s square plus 4 ds. Okay, now we have to solve this integration. Now from this, now answer of integration of 1 upon s is what, log s, and now we have to integrate this. So we will use this formula, that is integration here fx and here f dash x dx. This is what, log fx, right? So we will use this formula. So now we have in denominator s square plus 4, so its derivative is 2s, so 2s should be present over here. So we will just multiply it and divide it by 2 to get the required result. Okay, so minus 2s upon s square plus 4 ds. Okay, now integration of 1 upon s is log s minus this 1 by 2 as it is, and this integration is log s square plus 4. Okay, we have used this formula, and the limit is from s to infinite. Okay, now we will not substitute the limit directly, we will first simplify this and then we will substitute the limit. So for that, this what we will do, just take this 1 by 2 outside, so here you will get 2 log s minus log s square plus 4. Okay, this limit s to infinite as it is. Now we know this 2 log s is what, log s square. Okay, so this is 1 by 2 log s square minus log s square plus 4, correct? and the limits are s to infinite. Now we know log a minus log b is what? Log a upon b. So 1 by 2 as it is here, log s square upon s square plus 4. Okay, limits are s to infinite. Now again, to apply the limit, what we will do, we will divide this bracket by s square. Okay, so what you will get here, log here will get 1 upon 1 plus 4 upon s square. Okay, s to infinite. As we have to substitute this infinite limit, we need 1 upon s type of format, right? So that's why we are doing this process. Now we can apply the limit. Okay, so 1 by 2 upper limit. So here if you will substitute infinite over here, so 1 upon infinite is 0. So here we have 0, right? So we will get only log 1 as upper limit minus, now again in place of s we have to substitute s. So this will remain as it is. And just simplify this. So again we will get this term, right? That is log s square upon s square plus 4. Okay, this is our limit. Now we know answer of log 1 is 0. So the final answer is minus 1 upon 2 log s square upon s square plus 4. Okay, right? So this is the answer of Laplace transform of 1 minus cos 2t upon t. Okay, now next one. Find Laplace transform of cos at minus cos bt upon t. So firstly we will find Laplace transform of cos at minus cos bt. Okay, so this is s upon s square plus a square minus s upon s square plus b square. Now divide it by t, so you will get cos at minus cos bt upon t. This is what? Integration s to infinite fs ds. This is fs. Okay, so just substitute over here. So s upon s square plus a square minus s upon s square plus b square ds. Now again, to solve this integration, what we have to do, we have to again multiply and divide it by 1 by 2. Okay, so I am keeping 1 by 2 outside. Here we have s to infinite 2s upon s square plus a square minus 2s upon s square plus b square ds. Okay, now integrate it. So what we will get here, log s square plus a square minus log s square plus b square. Okay, this formula integration f dash x upon fx dx is log fx. Okay, we have used this formula. Now we cannot substitute the limit directly, so we have to simplify. Okay, so we will simplify like this, that is log s square plus a square upon s square plus b square. Correct? Now as we want to substitute the limit, so we need the format 1 upon s. So again we will divide it by s square, right? So 1 by 2 log, here will get 1 upon a square plus s square upon, okay, and here 1 b square upon s square. Correct? Just divide it by s square. Now we can substitute the limit. So on substituting the limit in place of s, if you will substitute upper limit infinite, so 1 upon s it will be 0. This term will be also 0. This 2 term will go to 0. We have only log 1, right? So this is 1 by 2 log 1 minus, now substitute the lower limit. So again in place of s we have to substitute s only. Okay, so we will get the similar term. Just simplify this, so you will get s square plus a square, s square plus b square, like this, minus log s square plus a square upon s square plus b square. Correct? Now we know log 1 is 0, right? So we have answer minus 1 by 2 log s square plus a square upon s square plus b square. You can keep your answer like this, or if you want to remove this negative sign, we can reverse over here. That is s square plus b square upon s square plus a square. Okay, so this is the final answer of this Laplace transform. Now let's discuss new topic, that is Laplace transform of derivatives. Okay, so if Laplace transform of ft is equal to f of s, then Laplace transform of f dash t, okay, its derivative is what? sfs minus f of 0. Next, Laplace transform of f double dash t is what? S square fs minus sf0 minus f dash 0. Okay, so in general, Laplace transform of f raised to nt is what? S raised to n fs minus s raised to n minus 1 f of 0 minus s raised to n minus 2 f dash 0 and so on up to f raised to n minus 1 at 0. Okay, so in this general formula you can substitute n and you can write this formula also. Now let's begin with the proof. A Laplace transform of f dash t is what? Integration 0 to infinite e raised to minus st f dash t dt. Okay, now what we will do, we'll integrate it by parts. Okay, so what you will get here, Laplace transform of f dash t is e raised to minus st as it is. Okay, now integration of f dash t is what? Ft, and the limits are 0 to infinite minus integration 0 to infinite. Okay, now we'll find the derivative of this term with respect to t. So this is minus s e raised to minus st. Okay, and again on applying integration to this term we'll get ft dt. Correct. Now just simplify this. Okay, so on substituting the limit over here, e raised to minus infinite, it will become 0, and e raised to 0, okay, it will become 1, and here we have f of 0, so we have only minus f of 0. Okay, now this minus minus will become plus, so as integration 0 to infinite e raised to minus st ft dt. Okay, now we know this integration 0 to infinite e raised to minus ft dt is what? Fs, right? So we have sfs minus f of 0. So Laplace transform of f dash t is what? Sfs minus f of 0. Okay, so similarly we can find Laplace transform of f double dash t. Okay, so what you will get, minus f dash 0 plus s Laplace transform of f dash t. Okay, now we know Laplace transform of f dash t is what? Sfs minus f of 0. Okay, so from this, on simplification, what we will get? S square fs minus sf0 minus f dash 0. Okay, so in general we can write that Laplace transform of f raised to nt is equal to s raised to n fs minus s raised to n minus 1 f0 minus s raised to n minus 2 f dash 0 up to f raised to n minus 1 at 0. Okay, so we will use this formula to solve this type of example. So first here we have to find Laplace transform of ft and Laplace transform of f dash t, where ft is given, that is e raised to minus 5t sin t. Okay, so whenever we will see this type of combination, okay, so we have to apply first shifting theorem. So for that, firstly we will find Laplace transform of sin t. Okay, we know Laplace transform of sin a t is what? A upon s square plus a square. Here a is 1, so we have 1 upon s square plus 1. So Laplace transform of e raised to minus 5t sin t is what? 1 upon here. Whenever we are applying e, so in place of s, we have to write s plus 5, correct? So this is s plus 5 whole square plus 1, right? So this is the answer. Now, this is the Laplace transform of t. So this question is solved. Okay, now we have to solve this. That is Laplace transform of f dash t. Okay, so the formula is sfs minus f of 0. Okay, this is our fs. So we have to just substitute fs and we'll just multiply it by s. So we have s upon s plus 5 whole square plus 1 minus f of 0. Okay, so this is the function f of t. So we will find its value at 0. Now e raised to 0 is 1 and sin 0 is 0. So its value is 0. So this term is 0. Okay, so your final answer is s upon s plus 5 whole square plus 1. Right? Next. Let's find Laplace transform of f dash t, where ft is equal to 3 and 0. 3 is between 0 to 5 and 0 for t greater than 0. Okay, now whenever the question is given in this format, we will use the main formula of Laplace transform of ft. Okay, that is integration 0 to infinite e raised to minus st ft dt. Okay, integration will be split in two parts, that is 0 to 5 and 5 to infinite, right? Now in the interval 0 to 5, the value of function is 3. So e raised to minus st into 3 dt, right? And in this one, we have answer 0. So here 0. Okay, so this integration is gone. Just 3 take outside, integrated. So e raised to minus st upon minus s, and the limits are 0 to 5. Okay, substitute the limit and take this minus 1 upon s outside. Okay, so here we have e raised to minus 5s minus e raised to 0, that is 1. Okay, just multiply this negative side inside. So what you will get 3 upon s. Okay, and this is 1 minus e raised to minus 5s. Okay, so this is your answer for Laplace transform of ft, and this is your f of s. Okay, we have to find Laplace transform of f dash t. Okay, so the formula is sfs minus f of 0. Okay, now as it is, fs is what? Just write down, that is 3. I am writing over here. Here s upon 1 minus e raised to minus 5s. Okay, minus f of 0. Now 0 is included over here, right? So f of 0 is what? 3. So here we have 3. This s will get cancelled. Multiply 3 inside, so you will get 3 minus 3 e raised to minus 5s minus 3. Again this 3 will get cancelled, so final answer is minus 3 e raised to minus 5s. This is Laplace transform of f dash t. Okay, now, so I hope you have understood both the topics. Thank you for watching.